Here's a couple trigonometric indefinite integrals. It's a big topic, I guess. All right. Let's get all of these trig functions into a form that we know. So this is 1 over cosine. And this is sine over cosine dx. And then we have sine, let's see here, sine x divide cosine squared x dx. And I'm going to bring this cosine squared up. So I have sine times cosine x to the minus 2 dx. All right, so now we're in a position when we can actually take the integral. So this is the main function here. This is our piece that we're dealing with. So that's definitely going to be cosine x, and then this is going to be add 1, so that's to the negative 1. Now, when I take the derivative of this, function, I get minus 1 cosine to the minus 2 times the derivative of the inside, which is minus sine, which is exactly what I have here. The minus times the minus is a plus, and look, it's done. That's what I have. So, plus c. This next one is a little bit more work before we even start to take the integral. In fact, that's not too uncommon. Most of the work is done before you even take the integral. All right, so integral 1 over sine x divide 1 over sine x minus sine x d theta. Oh, all these should all be thetas, I guess. Theta, theta, theta. Okay, so then this 1 over sine theta divide, I'll do a common denominator here. So I have 1 over sine theta minus sine squared theta over sine theta, all d theta. That's integral of 1 over sine theta divide 1 minus sine squared over sine d theta. And this, do a little reciprocal flipperoo trick, you're going to see that we get 1 over 1 minus sine squared theta. I don't have enough room, but I'll briefly show you what I did. That's the sine, divide the 1 minus sine here, sine, the 1 minus sine squared here. So those cancel, and I'm left with that, and everything cancels. So I'm left with this and this. All right, almost done. 1 minus sine squared is cosine squared d theta, and you should understand from your calculus unit that the integral of 1 over cosine squared is tangent. So look at all of this math that had nothing to do with integral calculus, and then the very, very last step was your only calculus piece.